2000. His area of research interest includes quantum dot cellular automata, machine learning, and AI. He has praiseworthy contributions in this area which were recognized by the reputed journals and conferences. He is also associated in research with the Department of IT, Tripura University. I thank you for accepting the invitation. The session is yours.
Thank you for giving me chance to say regarding this topic. Without taking any time, I want to start my topic today, and the topic is Weka in machine learning. So in that case, I am sharing one PPT. Give me 1 minute. Is it visible? The PPT visible from your side? Hello, am I audible?
Yes, yes, it is visible and you are audible also.
Okay, oh, thank you, thank you, thank you. So, the topic is mainly the Vega, how it can be used in case of machine learning. So before starting anything, I have divided my session in two part. First, I will tell the theory part or the mainly the theory part regarding Vega. After that, I will demonstrate the tool how to use for machine learning purpose. In that case, first Weka. Weka is mainly a name of the bird in New Zealand. From that name, the tool was named, and this one is invented or developed. This tool is developed by the Warwick University in New Zealand, and this tool can you can download from internet first. It is open source, so you can download from the website, and it can run in Windows system, Mac OS, or in any platform it can run. And it has a feature where you can upgrade or you can modify the coding. Means we know that in machine learning many types of algorithms are there, just like k-means, naive, many types of algorithms are possible. So this type of algorithm you can change the parameter also by going to the detail of the coding in the part of Wake. So many features are there. I will discussing in my subsequent part. Main feature or the main purpose of the Weka is that comprehensive set of data processing tools, learning algorithm, and evaluation method. It can be used for the data processing. Means suppose we have huge amount of data. Suppose we have a huge amount of data, and from this data it is very difficult to find out the trend of the data or the inner meaning of the data. But by using Weka, we can find out the inner meaning of the data, or we can visualize the data in efficient manner or systematic manner. This is come from the second part, graphical user interface, where we can visualize the data in a very good efficient way. And environment comparing learning algorithms, just like I have said, uh, it provides different types of machine learning algorithm, and by using this machine learning algorithm you can develop model or you can predict the value for some unknown values. In case of Weka, it supports only one type file, and the file is .arf. This ARF, it supports mainly supports, and in case the all the attribute first, suppose if I consider one data and it has four column, and each column has some name, and the name of this column is the attribute. So first we need to represent that attribute in this ARF file. Suppose if I explaining this slide, suppose I have taken one data, and the data comes from the heart disease platform or heart disease related. So that's why I have given, or the name of the relation, or the name of the data is given at the rate relation heart disease simplified. So this one is the field from where the data is comes from. After that, suppose consider that suppose data has 1 2 3 4 5 6 columns are there. So each column must be represented in terms of attribute, or the name of the column more specifically can be represented in terms of attribute. So this is the attribute. First, suppose the first attribute, the first column name is age, so that's why it is represented at as attribute age, and it may be it must be numeric type, that's why the age numeric. And the significance of this age numeric is age is the name of the attribute and the numeric is the type of the attribute. After that, the second column is sex, and that's why it again it is represented as attribute, and it may, possibly two types of sex as possible, male and female, that's why these two type is represented inside the curly braces. After that, another attribute is that chest pain type. It may be according to this data 1 2 3 4, four type of is possible, four types are possible. Types angina, asympt, non-aginal, and these are the four types are possible for chest pain. And another attribute is cholesterol, and again the cholesterol value must be numeric, that's why the attribute type is numeric. And next one is exercise induced angina. It is yes or no. In the last attribute, it is class present or not present. It means the it is heart disease yes or no, or the patient has heart disease or not. So that's why again two possibilities are there. That's why present and not present. Altogether, 1 2 3 5 4 6. Sorry, altogether six attributes are there, and each attribute is represented its corresponding type. And in some attributes, the possibilities also given, just like sex, chest pain type, exercise, class. For these possibilities also given. Now in case of data, now we need to represent the data in the one by one. First, suppose the first data is 63. Actually, 63 stands for age. Here, the first position is corresponding to the age. So that's why 63 is the age. Then the corresponding to the sex means in case this data, the sex of the patient is male. After that, the chest pain type, and then cholesterol value. Then it if he performs some exercise or not. According to this data, he did not perform any exercise. After that, the patient has heart disease or not present. So altogether 1 2 3 4, four data are there, and we can add more data in that manner. In the last data, you can easily find out that in that case there is a question mark. In case of cholesterol, there is a question mark, means unknown value. It may possible that some values for some attributes we don't know. In that case, we can represent using the question mark. It's the significance of this question mark is that we don't know the value. So that way we can represent any type of data in this specific format. After that, this format can be used in case of Weka. So that's why and that's the thing I have already discussed, numeric attribute and the nominal attribute. Next up, interface of the Weka I will tell in the subsequent. First in according to theory I am discussing that this Weka, this is a mainly 1999 to 2003 this version is going on. That's why it has altogether 1 2 3 4 options are there. But now which one I will discuss in my subsequent part, that one is 22 version, means 2022 version. It has five options are there, means five options means in this slide I have represented one main interface is there. In the main interface, in main GUI, four options are there: simple CLI, explorer, experimenter, knowledge flow. But it is the older version, which is the version of this is 2003, means 1999 to 2003 is going on. But currently we are using the Weka GUI version, which is 2022, and it has five options, and I will tell in the subsequent part. Means in simple CLI, it actually provides the basic knowledge or basic information of this Weka. In case of explorer, we can explore the we can explore the various types of data. Means various types of data means the thing what I have told you in the beginning. Means suppose we have large amount of data, and this amount of data can be visualized in an efficient way using explorer. Means what is the mean value, what is the average value, what is the trend of the data, we can everything we can visualize in efficient manner using the explorer. Next, in case of experimenter we can develop in any new algorithm using or combining different types of machine learning available algorithm. So this provides the experimenter knowledge flow. In case of knowledge flow, we can give one graphical representation, means in which way the experiment is going on. Means suppose we want to build one model. So in that, for to develop a model, first we need to collect the data. So this one is the first step. Then after that, we need to pre-process the data. Means pre-process the data means we need to clean the data, we need to eliminate the redundancy. Means various steps are there. So means we can summarize this in one time: pre-process the data. After that pre-processing, we need to divide the data in two parts: training and testing. And after that, test training data, we can develop the model. And after that, developing the model, we can uh, check the accuracy of the model by giving the test data. So this is the whole process can be graphically represented by using the knowledge flow. Means one type of knowledge is flown from collecting data to develop the model, and to predict the model can predict the output of any unknown data. So this one knowledge flow is there. So we can represent this knowledge flow by using different types of diagrams are there. So in that case, many diagrams are available. We can check in Weka. Many types of diagrams, diagram, diamond shape diagram, different type of diagrams are available for different types of part. Means different types of part means suppose one part is data collecting, another type is data processing, another type is data visualizing. So for different purpose, different types of diagrams or different types of shapes are there. So that's using that shape we can visualize, we can represent the knowledge flow. So first, as I have discussed, simple CRE is the basic part, or the simple CRE represents the basic knowledge of the Weka. So this one is completed. Now the next part is Explorer. So first, Explorer, as I have said, sorry, data can be imported from a file in various format: ARF, CSV, but CRF. But in case of now, the current version which is currently we are using, it's only supports, yes, ARF. I can I will see the format in after in the subsequent slide. Then after that, data can also be read from URL or from a SQL database. Then after that, pre-processing tools in Weka are called filters. Weka counts filters for discretization, normalization, resampling, attribute selection. Means many purpose different methods or different filters are there, or different using these different filters we can modify the data accordingly. So simple interface is there. uh, One thing I want to clear: I am not running the Weka. I will run the Weka in subsequent part when I complete this theory part. So before that, this one is one slide, the interface for Explorer I have taken from the Weka, and this the interface look like this one, and where the different options are there: pre-process, classify, cluster, associate, select attributes, visualize. These different types of options are there. By these different types of option, we can utilize the data and do some classification or clustering. So here, open file option. By open file, we can uh, add some data. In that way, add some data, any term data which is in ARFF format, and according to this, the data is attached in this Weka. We can easily find out that in the data name is, or the relation is iris, and it has instance 150, and it has it attributes 5. It has 5 attribute, means 5 columns are there in the data, and 150 instance means 150 rows are there. After that, here one attribute is selected, and according to that, this in the right part of this slide represents the different features or different significance of this particular attribute. So here the name of the attribute is there: shape, length, length. Then the type of the attribute is numeric. So missing means 0% means nothing is missing, all the data for these attributes are present. Distinct means 35 distinct status are there. means some repeated letters are there now, some non-repeated letters are there. Altogether for this particular uh, sepal sepal length attribute, 35 distinct letters are there. And then unique, 9 is unique, and altogether it is 6%. And the minimum value altogether calculated 43%, and the Weka can do the calculation. Maximum value is 7.9, mean is 5.4843, and standard deviation is 0.828. And this, the below the data is visualized representing the class. Means class means the class is our main target. Suppose if I say the example, according to this example, suppose I want to identify the class using these different parameter, different attributes: sepla length, sepla width, petal length, petal width. Depending on the these four attribute, we suppose we want to find out the class. Then this actually this the visualization mainly have done depending on this class. So suppose if I select the class attribute, then it can directly show that three distinct values are there. Means IDs, this different IDs colors are there, or different IDs class are there. Sorry, not color, class are there. And these colors, all the threes are distinct, and each of them are present for 550 different rows. Means altogether we have, as I have said, that 150 rows are there. For 50 rows, the class value is the first one. The for 50 rows, the class value is the second one, and for 50 rows, the class value is third one. It may be random way, it may be mixed way. It may not be in the sequence serially. Means the first class is present for continuous 50 values. After that, the second one, and then it may not be possible. It may not be possible. It may present at any way. Then it had visualized by using these three color, red, blue, and another color. By using these three color, these different class is visualized. So this is the visualization using for different class, for different sepla length, sepla width, petal width, and class for different attributes. That visualization is given here. Next here, the petal, if I select the petal length attribute, then again it will represent the information about this petal length attribute. And you can find out, you can easily check that in the right part the attribute is selected petal length. Missing is 0, means no values, every values, all the values are there. Then distinct is 43 and unique is 10. And again, this one is mapped, this petal length attribute is mapped with that. If I map this attribute, the class attribute, then it will look like that way. So again, we can choose any discretized way, discrete way to represent the graph. And then we can choose the another way to represent the class, and apply. If I apply the value variable, then we can, as graph, the visualization of the graph will be changed according to that way. Previously, the filter is, we have not chosen any filter, but in the same way, if I choose the filter discretize, then automatically in that way the data will be look like or visualized. Previously data will be sequential, means all the data, all the bars are connected to each other. In case of the right, this part, if I visualize, if I divide the visualized part in two part, one is blue part, another is red and sorry, orange and part. So in that case the data is uh, attached to one another. But if I apply this filter, then we can easily visualize that all the data, all the parts are randomized, sorry, discretized, means all the bars are separated, not connected to each other. Then building classifiers in the same way, the another approach or another way you can develop the classifier. In that way we can develop any model by using any machine learning algorithm. For that, Weka provides different types of algorithm. So this is the points mentioned over there. Classified in Weka are models for predicting nominal and numeric quantities. Implemented learning scheme include decision trees, instance-based classifier, support vector machine, support vector machine, multi-layer perceptrons, logistic regression based network. So it means that we have, in case of Weka, different types of algorithm are there available. So using any type of algorithm, we can develop the model for prediction purpose. Meta classifier includes bagging, boosting, stacking, error correcting output. Means we can boost the performance of a classifier. Suppose the performance of the classifier is not so good, not up to the mark. Not up to the mark. In that case, we have some parameter, boosting parameter, stacking, error correcting parameter. Many parameters are there. By changing the value of this parameter, we can boost the performance or the prediction performance of the algorithm or the model in a efficient manner, in a good manner. So many parameters are there. So in that case, for that purpose, we need to identify or need to choose the option or need to choose the tab classify. Next, we need to choose the algorithm. Default it will be 0R, and you can choose any algorithm. Suppose you can easily find out that in case of classifier based, that a function, meta, miscellaneous trees, random forest, random trees, many types of algorithms are possible. You can choose according to your requirement, and then we need to perform the we need to develop the model. For that purpose, we can do the cross validation faults for 10 fold. We can cross validate after that percentage of split in default it is 66%, but you can change, and it can from different experiment it was find out that it is better to split the data in 70-30 or 60-40 in that, or 80-20 in it in that manner. In this case 66 is split. It means 66 is the for training purpose, the rest of the data can be used for the testing purpose. Then we can start the procedure, we can start developing the model. And after developing the model, it describes different features or different information about this model. We can check that first the schema. Weka classifier trees. We have selected particular this algorithm. That's why it comes to the schema Weka classifier. Uh, this algorithm comes from trees algorithm. After that, relation is the file name or the relation name which we have used to develop the model. After that, instance, how many rows are there in the data. Then the attributes, how many columns in the data. Then test mode. We have split 66 strain reminder test. Means what I have said is 66% used for trading purpose, and the rest of the portion 34% is used for the test purpose. Then classify the model full training set. Then after that, corrected classified instance 49, then incorrectly classified instance 2. Means we have splitted the data, and the test for testing purpose we have 51 data, as it is 34% of that all data. And after this 51 data, the model correctly classified 49 data and incorrectly classified 2 data, and accordingly to that it given the percentage. Then kappa statistics, it is calculated depending on the formula which is present in the machine learning. And the same way, the mean absolute error, root mean squared error, relative absolute error, root relative squared error, and it is presented using the same formula which can be formalized, or which is present in the machine learning. And next is total number of instances. As I have said, the 34% of that all data, 34% of the total data is 51. So that's why the total 51 instance or 51 rows are used for the testing purpose. Then the detail accuracy is presented by total positive rate, false positive rate, precision, recall, F measure, and class. So in that way, again this TP rate means total positive rate, total false positive rate, and precision. Again, this one is calculated using the basic concept of machine learning. And next, the confusion matrix. Confusion, again, the confusion matrix is given as the it is described in case of simple basic concept of machine learning. Now you can visualize the data in the different way. Suppose we can visualize the tree view visualize the data in tree view, where the means every data is the data is represented, or the model is represented in using the tree view, where the first is the petal width, and it is the actually is greater than 60%, greater than equals to 60%, is less than equals to 0.6 is or 60%, then it is going to the corresponding classes. In that way, it's the basic concept of machine learning. I am not going into the detail of the machine learning because this session is mainly related to Weka. That's why I am not going into the detail how this tree view is represented for this model, because this concept comes from machine learning. Then visualize the classify errors. We have represented in that way the classify errors. So here different three classes are there, as I have represented in the basic part of the data. Three classes are there in data, so three parts are there. Then three keys errors is represented by this way, and this simple small rectangular shape is thing is that error, which is actually belongs to another class and comes to the another class. Means I want to say that this rectangular value shape value is, suppose this particular object or this particular data belongs to this class, but it actually belongs to the above class. In that way, this actually you can represent the error. Then clustering data. Weka also can be used for clustering purpose, finding group of similar instance. Same the concept of machine learning. We know that depending on the similarity, the machine learning algorithm itself identifies that which data belongs to which cluster. So Weka can be used for this purpose also. For this, again, for different algorithms are there, just like k-means and many others algorithms are there. By utilizing this type of algorithm, we can create different type of clustering based model. Clusters can be visualized and compared to true clusters if given. Evaluation based on log likelihood. If clustering can produce a probability distribution, means all if the clustering is done on the log likelihood based, so depending on the probability, the new data will be identified in which cluster it will go, or the new data belongs to which clusters. So in that same way, we can choose the clusters. Choose the cluster means the clustering algorithm. So suppose from the choose option, we can choose the clustering algorithm. It may be k means clustering, it may be x means clustering. Further, anyone we can choose depending on the circumstances or depending on the requirement. Again, use training set. Then we can classes for to cluster evaluation. Then we can start, or from classes for cluster evaluation, many options. We need to choose the class for which the cluster is means for which we need to identify the target class, means which one we need to predict. Depending on the attribute, we need to place this attribute in class to cluster evaluation. Means depending on the classes, means as I have said, the data has different the attributes. Altogether it has 6 attributes, and the class one, the class attributes, the last attribute. And suppose we want to identify the data belongs to which class, so that's why the class attributes comes into this tab. This one comes into this tab, classes to cluster evaluation. Suppose we want to create cluster for first attribute, just like sepla length. So we need to, in that case, we need to for this attribute, for this selection, classes to cluster evaluation, we need to choose that cluster, that attribute only. But in that case, we need to we need to create cluster for the class attribute. Depending on the class attribute, for this purpose we have chosen this class attribute in this in this tab. Then again, we can start the model, and again it will show the same type of information just like previous, just like schema. That's in schema we can easily identify that this particular type of algorithm we have chosen for clustering purpose. Again, the relation name, the instance and the attribute, and the test mode. With the test mode, which one we have chosen, the classes to cluster evaluation for training data, then clustering model, and number of merges, number of splits, number of classes. Because we are creating the clusters, for this we have not splitted the data. So in that purpose, so no number, there is number of merges, number of splits is 0, and number of cluster is 3. Why not the number of cluster is 3? Because again I am telling that in that particular column we have chosen the attribute class. Class means, again I am going to the beginning. Means here I can describe. Suppose you can at this one is also correct. One second. This one here in data altogether six attributes are there: sepla length, sepla width, petal width, and class also one attribute. But here we have used class is a target value, so that's why except the class only five attributes are there. So that's why the model identify the five attributes, and another one is a target attribute, and target attribute is class. And here class is we have selected the class attribute as a target attribute. That's why here number of cluster is three, because in the from the data I have shown that that mainly three, that according to the cluster three, according to the class three types of classes are there. So that's why three clusters are there. And after that node, means a node is created for 150, leaf 91, 96, and leaf to 54. That way can be represented cluster instance 150, means that all together the 150 data are there. So it is split in two cluster, 150, 67% and 33%. And now we can choose the another way, visualize the tree in the same way, just like what I have said. Keep total class is represented two class, means in class three altogether three classes are there, and after merging two class will be generated, leaf 1 and leaf 2. And 96, the first one 96 and 9, then one is 54. In the same way the error can be represented. And finding the association means you can I can see the simple and the very good example. Association, again the one concept of machine learning, where suppose we need to find out the association of one object with other object. Suppose the supermarket, the suppose the manager of the supermarket need to identify the which item will be sold in the last 3 days. To in that case, the manager can identify the association of one object with another object. Means suppose in the daily life, if I consider, whenever we are taking tea, at that time we are taking biscuit also. So it may possible that biscuit is associated with tea. In the other way, you can also say that whenever we are taking bread, we are taking also the egg, or we are also taking the butter. So there is a association between bread and butter or bread and egg. So in that fashion, in that manner, we can the manager of the shopping mall can identify that which item he or she, the manager saved in their warehouse, because suppose the manager has ordered for 50 bread. Suppose in that case he want to order another 25 or 30 slices of butter, because there is one association. But he or she, the means the manager will not order the water, because there is no association with bread and water. But if there is any association, then he or she, means the manager can order. So this type of association can be done also in using the Weka. So for that, this associate, we need to choose the associate tab. And then again, for association, one algorithm is there, apurity algorithm, and we need to choose the algorithm. So before that, for choosing the algorithm, first we need to preprocess the data. Means the preprocess means which type of data which related to another type of data. Just like suppose for this purpose we have from the Weka we have chosen another data. Suppose handicapped and infants. We have selected many, there is many types of data are there. So we have selected the data handicapped and infant for this association purpose. And next, if I start the algorithm, then again it will show that in that way the information of the algorithm or information of the model, it will provide the minimum numeric, the number of cycles performed, generated set of large item set, the size of the set of item set. Means this one, if I say the size of the set, so the size of set of large items at 20, means the it created many cluster one, I can say one type of not actually the cluster, but I can say the cluster type of word to say the association. Means one cluster is created for 20 items, as there is some similarity between these 20 items. Another cluster is L2 cluster is created for, means L2 association is created for 17 items, L3 is for 6 items, L4 for 1 items. So that's way different association is created depending on the relation of the one item to another item. So just like this one, based rules found some rules are found that adoption of the budget resolution equals to y physical physician free present in. Suppose it means that we have selected the data handicapped and infant. Suppose one parents who do not have any children going to the some orphanage, and he or the parents want to take one child. So one child, so how the parent will identify which child he or she need to select. So for this purpose, the association is that the child is must not be handicapped, the child is maybe good looking, but child is the child is has no disease. Which this type of association may come when the parents need to identify or need to choose one particular child. So means depending on this rule, depending on this association, the parents can select any one of the child that way. So this one is the one type of cluster is created, and this can be represented and that way. Then attribute selection panel that can be used to investigate which subset of the attributes are most practical ones. Means suppose uh, I can take the same example. Suppose one parents went to the orphanage, and he or she, the parents want to identify which child will be suitable for them. For that purpose, suppose they given one set of data, one data. In that data, the different attributes of the child is present. Suppose the attributes is name, age, if the child has any disease or not, if the child is handicapped or not, and many other attributes are there. But the from this many attribute, the main and the interesting attribute for this parent is the critical one attribute, just like whether the child is handicapped or not, whether the child has any disease or not. These are the main dominating parameter to for selecting the child for the parent. So that's why this one is the we need to identify this type of attribute out of many attributes, because it many times or many times it is not identified or not possible, not possible to do or to develop the model by using all the attributes. It may possible just like in bioinformatics. Suppose for one gene, if I consider one gene, many types of attributes are possible, but it may not possible, or it is not possible, it is very difficult to consider this all the attributes to develop the model. So in that case, we need to identify the dominating attributes, means the which one is the greater impact in the to identify the gene class. So in that we need to identify these attributes only. So this that's why this attribute selection is very much important uh, parameter, or a mainly important parameter to give the higher accuracy in the for the prediction of the model. So for that, attribute selection methods can contain two parts: a search method and evaluation method. For search method, based first, forward selection, random exhaustive genetic algorithm. For evaluation method, correlation based, wrapper, information gain, chi-square method. Many algorithms, many techniques are there. So this type of algorithm is actually very much known to the people who belongs to the AI and ML background. So these are the from this algorithm. Hello, am I audible? Hello.
Yes, sir, you're
Yes, sir.
audible.
Yeah. Okay. Again, I'm presenting where I have left. The PPT is visible from your end.
No, sir, the PPT is not visible.
Yeah, there is a network issue in our speaker side. So please be with us. We'll be online soon. Yes, Amit sir, is
Yes,
it
yes,
okay
yes.
now?
Am I audible?
Yes, yes,
Okay,
audible,
actually,
and
sorry for the
you can share.
disturbance. I have facing some network issue. That's why I have disconnected. But I hope that again it will not happen. Okay, anyway, I am starting where I left. Okay, is it visible? Hello, the PPT is visible from your end.
Yes, yes,
Okay,
visible,
okay, okay,
visible.
okay, okay. That's why. Again, I don't know how much you have listened. I don't know actually where, in which point I have disconnected. But again, I am summarize the slide. The attribute selection means in case of machine learning, the attribute selection is very much important parameter, because it depends how you have identified the attribute. Means many times, just like what I am taking the example. Suppose in case of gene, whether you need to identify whether gene belongs to some category or not. For that, many attributes are possible. Means thousands attributes are possible to identify or to signify that some genes belongs to some category or not. But every time to consider these thousand attributes or to develop a model by considering these thousand attributes is not possible. So in that case, we need to identify the dominating attributes, or the dominating attributes, or the in the attributes which has a greater impact in case to identify the genes. So this that's why the identifying the dominating attribute or the important attribute is a very much important thing, because depending on this identification, the accuracy of the model very much depends. So for this purpose, many algorithms are there. Suppose the search many search methods are there and evaluation methods are there. The algorithm which are presented in this slide, and this algorithm is very much known to AI people. I am not going to the detail of this algorithm, just restricted me to this Weka. Then in case of flexibility, Weka allows arbitrary combination of these two. Means from the searching method and evaluation method, many algorithms are there. We can combine any two or any of these two algorithm to identify the dominating attribute or the for the feature of the attribute selection. So for this purpose, select attributes. Again, we to choose the attribute evaluator and the search method. Attribute evaluator and the search method. So suppose next, use full training set, or we can perform any cross validation. Next we can start the procedure. Again, after starting, it will represented that that's after these many attributes it has identified these classes or these attributes, the main attribute, just like this one. uh, this one, based for start set no attributes, then search direction forward, then still search after 5 node expansion. Means there is one technique for 5 node expansion, or the expanding the nodes or the attribute. Total number of subset of evaluated 83, and merit of the best subset found 0.7293. Then the attribute subset evaluator supervised class nominal of 17 class, as CSP subset evaluator selected attributes 4:1. Means here, out of 17 attributes, one attribute is chosen, or we can say that this one is a 4:1 attribute. 4:1 way, the attribute or the dominating attributes identified. So in that way, I have covered the second part also, the Weka knowledge explorer, And then the performing experiment. As I have said, by performing different type of experiment, the Weka can help us to perform different type of experiment. Just like experimenter makes it easy to compare the performance of different learning schemes. Uh, for classification and regression problem, result can be written into file or database. Evaluation option, cross validation, learning curve, holdout can also iterate over different parameter settings, significance testing built in. Means the Weka provides us the platform where we can perform some different type of experiment. Just like this one, set up first. We need to set up first. One thing I want to clear, in the previous case, mainly in case of explorer, in case of experimental, in explorer you have find out that one option is there for classify and classic clustering, and where predefined algorithms are there. We don't need to hand, or we, in that case we cannot change, or we cannot twist or we cannot change the parameter of this particular algorithm. But in case of experimental, we can develop the total environment or total setup depending on our choice. This is the basic difference. There all everything is set or everything is predefined. Suppose in that case, in the previous case, suppose for clustering purpose we have selected one algorithm. Suppose we have selected an algorithm X, and this for X algorithm everything is well defined or predefined, not well, not predefined, and accordingly that the model will be built and it will be predicted. But in case of experimental environment, we can set up the environment. First option, open new. Suppose result destination, where we want to output the result. It may be some URL, it may be some URL, it may be some website. Then the experimental type, cross validation, number of hole 10, and the iteration control 10. It depending on the, then we can, suppose if I press the start button, then it start and finished, and it gives some time. Just like 10:33.04 second, the program has started and it completed or finished at 1:40, 13 colon 41 colon 15. Means at that time the program or the experiment has finished and there is no error. Then analysis, and in case of analysis, you can experience same, we can done the analysis part also can be done, but by using different types, by using the model we have developed or experimented. In that case, uh, it again represented the different parameters or different values. I'm going to not into the detail because I have very short amount of time. Next, knowledge flow, just like what I have said. Suppose I need to represent the in which way I have developed the model. So first I have collected the data, we have then preprocessed the data, then I have split the data in some percentage, then I have developed the model. A whole process can be represented in graphically. This one is the known as a knowledge flow. I have only 10 minutes, I think. I need to represent, or I have to show the actual Weka software. Okay, the software is visible from your side. The GUI of the software is visible from your end. Hello, hello. Is there any network problem? Hello, am I audible?
Yeah, sir, you're audible. It's visible.
Yes, the GUI is visible from your end. Okay, I have understood. Okay, anyhow, so that the with the NGUI, what I have showed in the I have presented in the slide. This one is a older version. As I have said that this one is a newer version 22. We can easily find out that the newer version is actually 22 version, means 2022, and it is 1, 2, 3, 4, 5. Five options are there, but the previous one has only the four options. So first, I'm starting with the Explorer. Uh, okay. Okay. First, we need to select the. I need to select the data set which I want to run. So for that, the when you will run, sorry, when you will install the Weka, Weka will itself come with some database. and this database is present in the program. If you go to the program files, then Weka, then data, and you can find out that many data, not many, but lots of data are there, and you can select any one of the data to represent the to visualize the data. So suppose here I have selected the data with whether nominal, or I want to select whether numeric. Suppose if I open the data, so it shows that the relation is weather, means the data name is weather, and it has 14 instance, means 14 rows are there, and attributes is 5, and sum of weights is 14. Attribute is 5, altogether 1 2 3 4 5 attributes are there. That's why it shows that 5 attributes. And now if I select any one of the attribute, then in the right part it shows that the selected attributes outlook, there is no missing data, distinct is 3, and type is nominal. Means you can, from this data you can find out that the first is number, means serial number 1 2 3. Then label of the data is, means in outlook three types of data are there: sunny, overcast, and rainy. And then count, means in the total data set, sunny occurs for 5 times, overcast occurs for 4 times, and rainy occurs for 5 times. So altogether 14 times are there. And weight is 5 for 5, means suppose for each occurrence the weight is considered 1, so 5 occurrence the weight is considered 5. In that way, for 4 occurrence weight is considered 4. And actually in this data, or the main purpose of this data, I can say that in that way, suppose one person wanted to go out from his or her home and wanted to play. So but he don't know whether it is the current scenario, current environment is correct to play some outdoor game or not. So but depending on this attribute, the person would need to identify whether this is the correct scenario to play outdoor game or not. Again, I'm repeating the scenario. Suppose one boy is there, and he need to identify whether the current environment is correct to play some outdoor game or not. The boy then identify or then check the some parameter or some attribute in the environment, and depending on the attribute, the boy will identify the scenario is correct for playing or not. So the attributes are that: outlook, whether it's a sunny, overcast, or rainy; what is the temperature, what is the humidity, whether it is windy or not. So depending on this four attribute, the boy will identify whether this is the correct scenario for play or not, to play the outdoor game or not. So in the same way that before that, so suppose there is a one mapping or visualization is there, depending on the for the play, means the
But
outlook. Yes,
the screen is not visible properly.
it is not visible. Okay, 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 okay,
GUI is not visible properly.
okay. Now is it visible? The graph, whether it's a orange and blue, this type of thing is visible from your end.
Oh, no, sir, no, sir.
Yes, okay, thank you. Sorry again for the sorry, I have not shared this thing, that's why it is not visible. Okay, anyhow, so this that way there is one mapping is there between outlook and the play and the,
Not presenting, sir.
sorry.
Right. It's visible now.
Okay, 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 okay. Okay, so here is one mapping is there between outlook and play, whether depending on this play, means in play two possibilities are there, whether either the boy can play or cannot play. So these two possibilities is mapped with outlook, and depending on this orange and blue, it will be identified whether the boy will play or not. So here I have shown I have mapped the play with play, and here 9 is yes and 5 is no. Actually, orange color represents no and blue color represents yes. So now the outlook, if again I have select the outlook column or outlook attribute, and I have, if map this outlook with play, then you can easily find out that as out of five thing or out of five sunny situation, three in three condition, the boy will not play, and for two condition or two sunny condition, boy will play. For four overcast condition, the boy will always play. But again for five rainy condition, two times he will not play, three times he will play. So that way mapping can be done. In the same way, temperature mapping can also be done, humidity mapping can also be done, and here the minimum, maximum, mean and standard deviation is represented. So if I consider that the data is not run through Weka, and if you only by physically checking the data to find out the minimum temperature, to find out the maximum temperature, is very much difficult if the database is very much large. But using the Weka, we can minimize this, minimize the time to find out the minimum value of temperature or minimum value of humidity. Okay, that we also can change the mapping. Means suppose here outlook to place, outlook is mapped to play, we can also change outlook to temperature. As there is no connection or there is no relation, that's why it is uh, that type of black. Outlook humidity, outlook no glass. So we can change the visualization parameter, but it actually visualization is possible only to considering the target class only. Okay, so this way we can represent the data. Now next one is classify. Again, for we can choose the different classifier. Suppose I want to choose random forest. We can choose that, I can choose a random forest. Then using training set, or I want to split the data, then in that case I will click that option. And suppose I want to split the data in 80/20, that's why I will put 80. And next, suppose the target attributes play. Again, you can change the target attribute, it may be outlook, it may be temperature, but according to the data, we need to, the boy need to identify whether he will play or not. So that's why I have chosen the target attribute play. Then if I start the procedure, it will again the it will first line, it will show the algorithm name in which, through which I have selected. Then the evaluation test split, then time taken for 0 second, then corrected classified instance. Out of total instance, the data is split in 80/20%. 20% means three data. So out of this three data, one is classified correctly, two is classified not correctly. In kappa statistics, mean absolute error, root mean squared error, relative absolute error, and these are the different parameters is identified depending the formula of the machine learning. Then TP rate means total positive rate, AP rate, false positive rate, everything is calculated depending on the machine learning. And after that, the confusion matrix is given. So this is the basic procedure for classification. In the same way, we can also do the clustering. Again, suppose if I choose the clustering with simple k-means, and then we can use the training set, we can supply test set, percentage split, cluster option, we can do that according to the our convenience. Suppose I have chosen the cluster to cluster evaluation, classes to cluster evaluation, means for which class we want to cluster, means we have some target class is play, and depending on this play class, we need to identify whether what's the scenario, the environment in which that boy will play, means for one yes class, one for no class. So again, if I start the procedure, then again it will show that out of 14 instance, 9 will 0, 9 will go to the 0, and 5 will go to the 1. And that way it's in that way it can be identified. 0 means for 9 condition, the boy will not play. For 5 condition, the boy will play, by combining all the four parameter. And the same way we can do the association. And suppose if I choose a pretty algorithm, and for that process and filter. Anyway, I have said, suppose missed anything, so due to that this one is not coming. So in that way, I mean, the thing is that in that way we can represent, we can use the Weka for different purposes, means to classify, for clustering, for association. And next is, again if I go to the basic part, this one, as I have said, simple CLI. So is the basic information is represented by is given for Weka. And experimenter, experimenter means as I have said, experimenter is a setup where it provides us the environment where we can run our program, or it also provides where we can represent our program, or where the output will be displayed. By this can be done using the experimenter. And then the workflow, as I have said two times, the work by workflow we can represent different steps of the process by using different diagrams. So if it's open, actually my laptop is a little bit slow, that's why it takes little bit time. So there you can easily find out that many options are there for data source, data sinks, data generator, filter, classifier, clustering, association. Means for different purposes you can identify different diagram, or different options are there. We can choose any one of the option depending on the, suppose from data source, suppose the data source is database loader, or you are collecting data from database, then in that case you will choose the option this one. Suppose you have formatted, or you had your data is present in a arf file, so in that case you will choose arf loader. Means depending on the requirement, or depending on your option, means from where you have identified the data, or sorry, from where you have selected data, depending on this situation, you can choose any one of them. Then after that you can choose from filter, any one filter, which one you have used, or which one you want to use. Then clustering, many class, after beginning clustering algorithm, you can choose any algorithm. Means actually, as I have said, knowledge flow represents the total procedure in terms of graphical view. You can say that in case of C, you have the term is known to you, flowchart. Actually, flowchart actually represents the flow of the executes. In the same way here, workflow, knowledge flow actually represents the flow, or the knowledge in which direction the knowledge is flows. It can be represented by this diagrammatical manner. The next, the last one, and the new one in the PPT, I have represented only four tabs are there: Explorer, Experiment, Knowledge Flow, and Simple CLI. Then the newer version, another tab is there, Workbench. Actually, Workbench allow us to combine any of them. Means any one of them, means suppose we want to jump from one time Explorer to experimenter to knowledge, or suppose we want to do some classification or clustering at the simultaneously. So this can be done by using Workbench. You don't need to go the separate tab or independent tab individually. Again, I am repeating, in Workbench, we can combine any two tasks easily. Means suppose I want to classify, I want to clustering, I want to set up my experimental, means I want to jump from one step to another step. This can be done by itself one tab. This one is Workbench. So that's all. I have given you the brief idea, not the detailed idea. I have given you one brief idea how Weka can be used, and Weka can be used for machine learning purpose, how to do the model, how to develop the model, how to visualize the complex data or the huge amount of data in simple way, to find out the inner meaning of the data, to find out the minimum value. Suppose in case of temperature, suppose find out the minimum temperature or the average temperature. Means the one thing is that, means the I have given you, I have represented you how to find out the inner meaning, or what is the inner meaning of the data. We can easily represent by using the Weka. That's all from my side. If anyone has any question, they can share. Anyone have any question, they can share. If anyone have any question, they can share. Either otherwise, that's all from my side.
So, Thank you, participants, for listening this session, and thank you, Amit Kumar sir, for your valuable talk. We are grateful that you have agreed to deliver talk in this workshop. Thank you, sir.
Thank you, sir, very much for um, giving me chance to deliver my lecture this valuable in this valuable FTP. So thank you again. Thank you, and to thank you the all the coordinators and the organizing team. Thank you, sir.
The second session would be taken. Second session will be taken care by Dr. Samrat Goswami of Department of Rural Studies, Tripura University. It would be in offline mode, of course. But before that, please be sure that you have given your attendance in the attendance sheet, and please check whether your name has been printed correctly or not, because this correction would be reflected in your final certificate. And of course, sir has circulated the criteria for the certification. That minimum 80% attendance and this one test would be conducted. So based on that, it is same for offline and online participants. So based on that, the certificate would be issued. Uh, and he will circulate. You have circulated. Okay, so you have circulated. Please make sure that your name, designation, your whether you are MC student, PhD scholar, or a faculty member, or whatever it has been printed correctly or not. If any rectification or modification required, please correct it in the sheet itself. Accordingly, we will take necessary action to modify them and prepare the certificate for that. And for the next session, before the next session will be of course we'll be having one lunch break. But today this lunch break, lunch will be provided after 1:30 p.m. And the next session will be starting at 2:30 instead of 2. So we'll be resuming at 2:30 p.m. with the session. But before that, from 1:30 to 2:30, it would be the lunch break for today. Thank you.